Hey, and welcome back. Today we are breaking down IPv4 addressing and subnetting, what it is, how it works, and how it's not nearly as complicated as everyone thinks it is. Also, this video is going to be more of an introduction type video and a much more in-depth video on how to subnet, the math behind it, and how to subnet a subnet will be coming out in the future. Simply put, IPv4 addresses are like digital street addresses for any device on a network. Every computer, phone, tablet, or router needs to have one in order to know where they're sending their data to, just like how every piece of mail needs to have a destination. Subnetting is simply just taking a neighborhood and dividing it into smaller, more manageable sections so that way traffic can flow easier and not get overcrowded. Think of it like a large apartment complex. The street address gets you to the building, but it's the apartment numbers that get you to the exact door. IPv4 addressing is the street address, while subnetting is adding the apartment numbers so that way you know exactly where to send your data to. Okay, so now let's get a little bit more technical with it, and stick with me and I'll do my best to try to explain it as simple as possible. IPv4 stands for Internet Protocol version 4, and it uses a 32-bit system divided into 4 octets, each ranging from 0 to 255. An example of this would be 192.168.1.10. Each address is made of 2 parts, the network ID and the host ID. The network ID identifies the network itself, like the street name. The host ID identifies the specific device that is on the network, like the house. The subnet mask, on the other hand, tells computers where to draw the line between those 2 parts. For instance, a subnet mask would look like this: 255.255.255.0, meaning the first 3 octets of our original example, 192.168.1, identifies the network, and the last octet, the .10, identifies the host. These patterns come from classes of IP addresses, class A, B, and C. Class A is 1.0.0.0. These are for really big networks. Class B is 128.0.0.0. These are for medium-sized networks. And Class C is 192.0.0.0, and these are for smaller networks. These are all for public IP addresses, by the way. Now, modern networks don't really rely solely on these old classes anymore. We use something called CIDR, CIDR, classless interdomain routing notation, like /24, /26, /8, which simply shows how many bits belong in a network portion. Now, classless interdomain routing is basically shorthand for subnetting, and subnetting takes a single network and divides it into multiple smaller ones called subnets. This allows for better organization, improved security, reduced broadcast traffic, and more efficient IP address use. For example, a network 192.168.1.0/24 has 256 addresses. Now we can split that into 2 different subnets, /25, and now we have 192.168.1.0 all the way to 192.168.1.127, and 192.168.1.128 all the way to 192.168.1.255. Notice that because we are in the class C, our only octet that is changing due to our subnet is the last octet. Both of these subnets each have 128 addresses, smaller, cleaner networks that are easier to manage. Okay, so to wrap all of this up, IPv4 addressing and subnetting can sound kind of complicated at first, but in reality, it's just helping you organize and separate your digital real estate. Once you understand networks and hosts and how their masks help define their boundaries, everything kind of just falls into place. And like I said earlier, I am going to come out with a much more in-depth video about subnetting and subnetting a subnet and the CIDR and how all of that works. That will be coming in the future. But other than that, that is the entire video. I hope you enjoyed it. If you did, hit that like button, subscribe so that way you don't miss out on further content, and like always, work with what you got and build what you need, and I'll catch you in the next one.